Good morning, grade nines. Today's Thursday, April 16th. Today, what I'm going to talk about is energy input and output. So we're going to talk about how efficient devices are. Now, don't forget, we gave you a project on Tuesday, April 14th. The project is due Monday, and it's due before 8:30 a.m. on Monday. So please make sure that you complete that project. You're making a little video for us. We're excited to see what you come up with. All right, let's do a little recap. Let's do a little review here. An electric motor is a device that transforms electrical energy into mechanical energy. So let me just slow down and explain. A motor would be something that moves. And the reason I know that it makes something move is because it makes mechanical energy. Mechanical means moving. Now, the thing about a motor is that in order for a motor to work, it needs electricity. So think of like your microwave. I know in my microwave, it has this little table that turns. That's a motor. Think of your blow dryer. Your blow dryer has a fan inside of it that blows the hot air out. So that motor, what you have to do is you have to plug it in. When you plug it in, the electricity goes in, and then it makes the motor go, and it turns so that it will blow the air out of the blow dryer. So that's what motors do. They take electricity and they turn it into movement. It's why we love cars so much, because all we have to do is turn them on, and the electricity is going to make the motor turn. So the wheels are going to move. This is made possible by permanent magnets, an armature, brushes, and a split ring commutator. Now, we didn't really go over the motor. Since we are in homeschooling, it's something that us grade 9 teachers, we decided to just kind of push aside for now. We just need you to know that there's all these parts that are inside of a motor, and generators actually have the same parts. But in the case of a generator, it's doing the opposite of a motor. It's going to take movement and it's going to make electricity. So when you move this part, it's called a turbine. When you move that inside of a generator, it's going to make electricity. Now, generators can produce direct current, or they can produce something called AC, alternating current. Alternating current is the most common form. This is what power companies are going to give us. So the current that's coming into your house right now, coming out of your plugins, that's AC, that's alternating current. Power companies use high voltage transmission lines to get electricity from the generating station to your home. We're talking 500,000 volts. So massive amount of voltage. However, the power line that goes into your house is only 240 volts. So that's all that comes into our house. Now, what's a transformer? A transformer is this thing that can step up or it can step down voltage, depending on what we need it to do. So inside your house, voltage is dropped again to 120 volts for most appliances. Let me go get a very common transformer that you probably own. How many of you have something like this at home? So this is what I use to charge my cell phone. This little cube right here is a transformer. The amount of electricity that comes out of the wall is 120 volts. That's way too many volts for a cell phone. So what happens is you plug this into the wall, and it takes 120 volts on this side, and it only lets out so many volts on the other end. It's stepping down the amount of electricity that goes through it. So this is a step-down transformer. Now, how does it work? Inside this transformer, I'm going to get my whiteboard. All right, so let me show you what's inside of a transformer. Inside that little cube, there's a coil, a metal circle inside of it. So on this side here, where it's the plug-in, okay, 120 volts is coming out of the wall. So on this side, there's a whole bunch of electricity. So on this side of this piece of metal, there's lots and lots of coils of wire around it. Now, on this side, we only have a couple of coils of wire. The more coils of wire, the more electricity. So on this side, there's 120 volts. But coming out of it, since there's only maybe 2 or 3 coils, maybe there's only 10 volts coming out. So because of that, we've got ourselves a step down transformer. Now, what power companies do is they do the opposite. They have step up transformers. This is what you might see at a big power plant. So what they have is inside their transformers is, again, a metal ring. Metal because it conducts electricity. Now what they do is on this side, they only have a little bit of electricity. But on this side, what they do is they put lots and lots of coils. So maybe they only have to put 10 volts in, but they can get 500 volts coming out of it. So that's what we call a step-up transformer. Now it's time for the sad news. You need to get out your calculator. We're going to be doing some calculations today. The first one we're going to be calculating is power. Power is the rate at which a device can convert or use energy. Power is measured in something called the watt. So it's the symbol W. And the formula is P equals I times V. Now I, just like it was before in Ohm's law, I stands for current. So it's measured in amps, the letter A. And V is for voltage, and that's measured in volts, which is the letter V. So power is current times voltage. So here's an example. Let's try and do this one together. You want to figure out how much power is being used when the smart board uses 120 volts and 0.2 amps of current. So step one, what we need to do is we need to know what the formula is. So it's P equals I times V. So P, we don't know that. That's what we're going to solve for. I, 0.2 amps, and V, 120 volts. So the best thing that I would suggest is always write down all the things that you know and then what you don't know. What are you going to be looking for? Now step two. Now you write down the formula. So P equals I times V, or V times I, same exact thing. Now that you know your formula, let's substitute in. So when we substitute in, you should always be substituting with units. So I'm going to actually add those. 120 volts times 0.2 amps. And that's all taken from right here. So 120 times 0.2. So what you do is you get your calculator and you put that in. 120 times 0.2 gives you 24. Now don't forget units. W, watts. Let's try example number 2. If a kettle uses 25 watts of power and 120 volts, what current is being used? So again, let's write down everything we know. P, power, is 25 watts. So we're just going to copy that right here. Now, it says it uses 120 volts. So we're just going to write that right here. What current is being used? So we want to know current. Current is I. So this is really the most important step, because if you make an error here, you're never going to solve it correctly. So make sure you write down what you already know and what you don't know. And now what we're going to do is we're going to substitute in. So we need to get our formula. Now, instead of it being P equals V times I, we have to change the formula. So it's I equals P divided by V. Now over here, you're going to see this little, I'll move it here just because I'm over here and you can't see me. I equals P divided by V. So this triangle can help you come up with any of the formulas. So P, power, equals V times I. When the letters are next to each other, it means multiply. When a letter is over top of another letter, that means divide. So I equals P over V. There's our formula right there for you. Put this back here. So let's plug in the numbers. I equals P divided by V. I equals 25, let's keep those units, watts, divided by 120 volts. When you put that into your calculator, you're going to get 0.21, and that would be amps. Because it's current, the unit is A. It's really important that you keep those units as well as the numbers. Now, another formula that you're going to have to do is energy. Now, energy is the rate at which a device uses power. It's measured in the unit called joules, J. So E equals P times T. Now, here's the thing about T. T is time. But in order for energy to be in joules, then time has to be in seconds. So it's going to be how quickly this device can use the power in seconds. So we're going to do this one first. If you want to determine how much energy the skateboard is using when it uses 1.2 watts of power, So since it's in the watts and we know that it's power, we put it in here. P equals 1.2 watts. Now this is the hard part to the question. It's on for 480 minutes, which means 8 hours of the day, the smartboard. So if it's on for 8 hours, we have to first turn that into minutes. So how did we get 480 minutes? We times it by 60, right? Because there's 60 minutes in an hour. So 8 times 60 is 480. Now the problem is that we can't use time in minutes. We need to turn that into seconds. So what we need to do then for time is we need to turn this into 480 minutes times 60 seconds. So when you do that, you get 28,800 seconds. So this part is going to take you a while to make sure that you have everything in the right units. Power is in watts, time is in seconds. Now that we have that, we just can substitute in. So first we write down the formula, E equals P times T, and we substitute. P is 1.2 watts, and time is 28,800 seconds. Once you have that, you multiply them together, and you're going to get an answer in the unit J, J meaning joules. How much power is being used by a kettle that uses 15 joules of energy and is on for 5 minutes? So what you do is you write down what the question's telling you. So it says that the energy is 15 Js, so 15 joules of energy. So we know that E equals 15 J. We know it's on for 5 minutes. So time equals 5 minutes. But you and I both remember, we can't use minutes. We need it to be in seconds. Now there's 60 seconds in a minute. So to go from minutes to seconds, we need to times by 60. So 5 minutes times 60 seconds is 300 seconds. Now, once we have that figured out and we know we're looking for P, the next step is we need to write down the formula. So the formula this time, it normally is E equals P times T, but we're looking for P. So P equals E divided by T. So what we have now is the formula, and we just need to substitute in. So P equals 15 joules divided by 300 seconds. And when you put that into your calculator, you're going to get 0.05. And then don't forget units, W. W means watts. Power is measured in watts. Now, although energy is in joules, and we take power in watts and time in seconds, we don't always measure things in seconds. In fact, seconds can get very, very, very big. So what we like to do is hours. So when we pay for our electricity with EPCOR, we pay for it in something called kilowatt hours. So instead of watts, we actually talk about 1,000 watts, kilowatts. And instead of seconds, we talk about hours. So kilowatt hours are used to determine how much energy is used by common electrical devices that use a lot of energy. So the number of kilowatt hours is how we are going to be calculating energy as well. So you've got to be able to do both. So I'm just going to scroll back up here, and I'll show you an example. That one's too small, but this one's good. So for example, although we could solve this and we could get an answer in joules, we could change it and turn it into kilowatt hours. So what we do is we take the watts and we divide by 1,000. So 1.2 divided by 1,000 would give us kilowatts. So let me use my calculator and do that. 1.2 divided by 1,000 is 0.012. So that would be how many, I'm just going to even write that in there for a second, 0.0012 kilowatts. Oops, made a little mistake. Now, 480 minutes it's on for. But look at that, it actually tells me right here 8 hours. So I could just change this and make it 8 hours. So if I wanted to make this into kilowatt hours, I would just go 0.0012 kilowatts times 8 hours. And if I put that into my calculator, I would have gotten oops, I did it again. Kilowatt hours. 0.008 kilowatt hours. Let's just make sure I did that right. 0.0012 times 8. Oh, I did do it wrong. 0.0096 kilowatt hours. So because it's so small, we didn't do that in this question. We kept it as energy is in joules. But I want you to understand you could do it in kilowatt hours. And a lot of times we do use kilowatt hours. So on your assignment, you're either going to have to determine if you should change it into kilowatts and hours, or if you should keep it as watts and turn this into seconds. So you have to remember both. You're probably going to want to refer back to this video a couple times when you're doing your work today. All right. Last thing is the law of conservation of energy. Energy cannot be created or destroyed. It just changes forms. So right now, I'm drinking some coffee. Lovely. Coffee is chemicals. And those chemicals are going to go into my body, and now it's going to change from chemicals into mechanical energy. My heart's going to be able to beat. My brain's going to be able to think. My arms are moving. My eyes are blinking. My mouth is moving. Your favorite part. So that's what the law of conservation of energy states, is that energy, you can't make it. You can't destroy it. It just changes from one kind to another. So this is a good picture. The electricity goes into the light bulb. Now, it doesn't stay as electricity. What it does is it turns into light that comes off of the light bulb, and it also makes heat. And that's why when you touch a light bulb, it's hot. So it's turning from one kind of energy into another kind of energy. You can see that the energy was transferred from the ball to the pins when you go bowling. So when you roll that ball, that mechanical energy goes down the alley. And when it hits the pins move. So that's mechanical energy, but also sound energy. You can hear the pins get hit. So if we put 100 kilojoules into a system and the device does 75 kilojoules of work, well, where's the other 25? What happened to the other 25 kilojoules of energy? It's missing, it's lost. But we just said you can't miss, you can't lose energy. So what we do is we take how much energy we put into a system and we figure out how much usable energy comes out. And then we can figure out how efficient a device is. So this is another math that you're going to have to do today. This formula is about efficiency. So how efficient a device is the ratio compared to how much energy you put into it and how much actually comes out that's usable, that's what you want it to do. And that's what we call work. So percent efficiency, joules of useful output divided by the joules of useful input. And we times that by 100 so that we can get a percent. So here's an example. Let's go through a light bulb. Now, a light bulb, you could put in 100 joules of electricity, and you'll only get 5 joules of light coming out of it. But the other 95 joules is heat. So what we have to do is we need to divide. Now, it says we're going to focus more on efficiency in our next lesson. So We'll do more calculations in our next one. What I want you to focus on today is power. Power is measured in the unit watts. Energy is measured in joules. And time is measured in seconds. Now, it's very important that you maybe copy this. You write this down. You put this into your notes. Power is the formula. Power is equal to energy divided by time. Now, however, power is not usually calculated by energy and time. Instead, electric power is more commonly calculated with electric units, as we learned at the start of this lesson. Power is measured in watts, and current is measured in amps, and voltage is measured in volts. And power equals current times voltage. So these are very, very important formulas. This is a very important slide for you. So what's going to happen is we have some calculations we'd like you to complete. So we've gone over the formulas. We've done some examples together. I would like you now to feel free to go back to those formulas, rewind this video, open up the Google Slides, look through them, and you're going to go to your Google Classroom, and there's going to be a bunch of practice questions for you to complete. So we want you to do the math. Now, this is going to take you a little while to do the formulas and the substitution. Don't forget units, and then coming up with the answer. Once you're done that, don't forget your project is due on Monday at 8:30 a.m. So it's only Thursday today. You still have Friday, Saturday, Sunday. So you've got 4 days ahead of you. Please make sure you finish your project and make sure you finish these calculations and you submit. Have a great weekend, guys. If you need any help, hey, show up. Yes, definitely. Oh, I can't believe I almost forgot this. Come today to the Google Meets. Mrs. Omijar and I can help you so much with those calculations. I'll do them on my whiteboard and I'll help you out. So our first Google Meet today is at 11:30 till 12:30. And our second Google Meet is going to be at 2:30 to 3:30. So hopefully we'll see you today. Bye, guys. See you later.